Welcome to MRL. In this learning session, we'll be learning about surds. A surd is an irrational root of a rational number. Nth root of a is a surd. If a is a rational number, n is greater than 1 and a is not equal to b raised to n. Remember that. Every surd is an irrational number, but every irrational number is not a surd. So let us understand this statement. Root 2 is a surd because root 2 is an irrational number. Root 4 is not a surd because root 4 is equal to 2, which is a rational number. Because 2 is a rational number here, therefore root 4 is not a surd. Square root of 2 plus root 3 is not a surd because 2 plus root 3 is not a rational number, because the definition is very clear. A surd is an irrational root of a rational number. Since here it is irrational root of an irrational number, therefore it is not a surd. So please remember that. The general form of a surd. The general form of a surd is nth root of a raised to p is the general form of a surd, where root of nth root is known as the radical sign. A is a raised to p is the radicand, p is the power of a, and n is the order of the surd. So there are different parts in the general form. First of all, nth root is the radical sign, a raised to p is the radicand, p is the power of the radicand. Sometimes they take a as the radicand and p is the power, and n is the order of the surd. The index form of a surd. We can express the nth root of a raised to p in index form as a raised to p whole raised to 1 by n, or a raised to p by n is the index form of a surd. Very interestingly, you should remember that n, which is the order here, becomes the denominator of the power, and a raised to p, the radicand, here the radicand becomes the base of the index form. So like that we can convert the surd into index form. The fifth root of 12 is a surd, or 12 raised to 1 by 5 is an index form. Radicand becomes base and order becomes the denominator of rational index. Remember that. Now the simplest form of a surd. Nth root of a is a surd. If nth root of a is equal to b times nth root of c, then b times nth root of c is the simplest form of surd. Nth root of a is a pure surd, b nth root of c is a mixed surd. So simplest form of a surd means expressing a pure form of surd into mixed form of surd, where b is a coefficient and nth root of c is a surd. So remember that. Now coming to, for example, root of 98 can be written as root of 49 into 2. This is a pure surd. Root of 49 into root 2, root of 49 is 7 root 2. So it is a product of a rational number and irrational number. It is 7 root 2, which is the simplest form of root 98. Therefore, the pure surd is converted into mixed surd, or the simplest form of the surd, and that is what you have to understand. So that is the simplification of any given surd. Now like surds, root 2, 2 root 2, 5 root 2 are like surds. If you observe here, root 2, root 2, root 2 are the surds. Coefficients can be anything. That means the surds are like, they have the same order. Order is 2, 2, 2 here, and they have the same radicand. Radicand is same. The coefficients can be anything. Unlike surds, root 2, root 3, their radicands are different here, therefore they are not like. Root 2, 3, that is cube root of 2, orders are different. Here order is 2, here order is 3. Here both the radicands and orders are different, and therefore they are unlike surds. So to identify the like or unlike surds, convert the surds into simplest form. So please remember, if you want to compare surds and segregate them into like surds, or group them into like surds and unlike surds, first of all you have to write them in their simplest form. So I learn how to remember or how to find out the like surds and the unlike surds. Now identify the surds as like or unlike. Now let us take example here, cube root of 24 and cube root of 81. Cube root of 24, first of all write it in simplified form. This can be written as cube root of 8 into 3, cube root of 8 into cube root of 3, that is 2 cube root of 3. So this is the simplest form. Cube root of 81 can be written as cube root of 27 into 3, cube root of 27 is 3, cube root of 3 as it is, and you find here the radicand is same, the order is same, therefore they are like surds. Now making orders same. Now if you observe here, we have got 4th root of 64 and 6th root of 28. The orders are different here, 4 and 6 are the different orders. So if you want to make the order same, the very simple method is first convert them into index form, that is 64 is to 1 by 4, and 6th root of 28 will be 28 is to 1 by 6. I have already told you, if the order becomes the denominator of the index okay, the power or the rational power. So now write this, if you observe here, this is 4 and this is the denominator is 4, denominator is 6. So find the LCM of 6 and 4. LCM of 6 and 4 is 12. So make the denominator as 12. If I make the denominator 12 here, I have to multiply the numerator by 3. So 3 by 12. Here I have to multiply by 2, 2 by 12. Again it will be 12th root of 64 raised to 3, 12th root of 28 raised to 2. So I have made the order same here, 12 and 12. So the procedure of making the order same is convert them into index form, make the denominators same, and by writing the equivalent rational numbers, and then reconvert it into the Surd form. That is how we convert. So making order same is required in certain operations on Surds. So that is the reason why we learn it. Now coming to the comparison of Surds. If you are asked to compare two Surds, 4th root of 7 and 3 cube root of 4, comparisons means what? Whether which is greater and which is smaller, or whether they are equal, or which is greater and which is smaller is what is the meaning of comparison. So 4th root of 7 and cube root of 4, first of all the orders are different, so we cannot compare. The orders are different, so first convert the order, make the order same. 7 raised to 1 by 4, that is convert that into index form. Then 4 and 3 are the denominators here, not same. Take the LCM of 4 and 3, make the denominator same. So 12 and 12, automatically I have to multiply the numerator by 3 here and by 4 here. So it will be 12th root of 7 cube, 12th root of 4 is to 4. Now 7 cube is 343, therefore 12th root of 343. Here 4 is to 4 is 256, 12th root of 256. We know that 343 is greater than 256. It means that 12th root of 343 is greater than 12th root of 256, but 12th root of 343 is 4th root of 7, and 12th root of 256 is cube root of 4. The 4th root of 7 is greater than cube root of 4. So that is how we compare two Surds. Now let us take one more example. Compare square root of cube root of 12, cube root of 4th root of 138. Now square root of cube root of 12, cube root of 4th root of 138, convert them into index form first. So now 12 raised to 1 by 3, so this will be 12 raised to 1 by 3 raised to half. This will be 138 raised to 1 by 4 raised to 1 by 3. I have converted them into index form, remember that. Now 3 into 2 is 6, multiply, that is, you know that a raised to m into n is equal to a m n, so it will be 12 raised to 1 by 6. Same way here, 4 into 3 is 12, 138 raised to 1 by 12. That means 6 and 12 are different, denominators are different, make them same by taking the LCM of 6 and 12, and multiply the numerator by 2 here, 2 by 12. Here it is 1, it will remain same. Then reconvert them into index form, that is Surd form. 12th root of 12 square, 12th root of 12 square, 12th root of 138 raised to 1, 12 square is 144, 138 raised to is 138, and you know that 144 is greater than 138. If 144 is greater than 138, that means 12th root of 144 is greater than 12th root of 138, but 12th root of 144 is square root of cube root of 12, and that is equal to, that is cube root of 4th root of 138, and therefore square root of cube root of 12 is greater than the cube root of 4th root of 138. So this is a very simple method, but only you have to know how to do it. The procedure is very simple. Convert the Surd form into index form, make the denominator same, make the order same, and then after that compare the radicands. Whichever the radicand is greater, that will be the greatest Surd. Remember that. Now writing Surds in ascending order. Ascending order means writing them from small to big, or big to small, descending order or ascending order. We can follow that. Now the procedure is very simple. Now let us take one example here. 4th root of 5th root of 8, 6th root of 4th root of 16, and we have 5th root of 6th root of 24. Now first write them in the index form, and the index form is 8 raised to 1 by 5 raised to 1 by 4, 16 raised to 1 by 4 raised to 1 by 6, 24 raised to 1 by 6 raised to 1 by 5. Now convert them into 5 4s are 20, multiplying a raised to m raised to n is a raised to mn, and here also 24, it is 30. 20, 24, 30 are different denominators, so take their LCM. LCM is 120, so make the LCM same. So if you have to make the LCM same, then I have to multiply this 20 by 6. So it is 6 to the 12, it is not 60 here, it is 6, please remember that, it is 6 not 60, 6 by 120, this is 5 by 120, and this is 4 by 120. Now that means it is 8 raised to 6 by 1 by 120, 16 raised to 5 1 by 120, 24 raised to 4 1 by 120, and you know how to write this because it is AMN. I have gone back to AM raised to n here. Now compare 8 raised to 6, 16 raised to 5, 24 raised to, because 1 by 120, 1 by 120, 1 by 120 is the same. Therefore, I can compare 8 is to 6, 16 is to 5 and 24 is to 4. Now I can convert the 8 as 2 cube raised to 6, 16 as 2 raised to 4 raised to 5 and 24 as 2 cube into 3 raised to 4, and this is 6 into 3 is 2 raised to 18, 5 into 4 is 20, and this will be 2 raised to 12, 3 raised to 4. Now if you observe very carefully, 2 raised to 12, 2 raised to 12, 2 raised to 12 is common to all, so I can neglect that. Take 2 raised to 6, 2 raised to 8 and 3 raised to 4 and then compare again. So 2 raised to 6 is 64, 2 raised to 8 is 256, 3 raised to 4 is 81, and we find that 256 is greater than 81, greater than 64. That means 256 belongs to 2 raised to 8 and 2 raised to 8 belongs to 6th root of 4th root of 16, and that is the greatest here. That is and then we have next one is 81, 3 raised to 4 and 4 raised to 4 belongs to 5th root of 6th root of 24, and last one is 4th root of 5th root of 8. So that is how we compare the surds and also write in ascending order or descending order.